Good morning, my mathematicians. Today, we're going to talk about GCF, or the greatest common factor, and how to find it. As a reminder, even though we're not in person today, remember, when you come to class, always have out a pen or pencil and your pad of paper to take notes on. Let's start off with some prior knowledge, some vocabulary. What is a whole number? A whole number is positive integers, including 0. So, what would that include? 0, 1, 2, 3, and so forth. My question to you, what do we call just these numbers? Right, just these numbers are our positive integers. But when we include 0, this set is now called our whole numbers. What is a prime factor? A prime factor is a whole number greater than 1 that cannot be made by multiplying other whole numbers. So, for example, let's look at the number 13. Besides 1 and itself, can we multiply any other whole numbers to equal 13? No, right. So that means 13 is a prime factor. Some other prime factors include 2, 3, 5, 7, 9, 11, 13, 17, 19, 23, and so on. Remember, these numbers cannot be multiplied by any other whole numbers besides itself and 1. Okay, let's get started. So there are two strategies when trying to find the greatest common factor, or GCF. I'm going to walk you through the first strategy now. Example 1. List all of the factors when multiplying 8. Okay, so in other words, what numbers can we use to multiply to get to 8? Right, we have 1 and 8. What about 2? Right, we can do 2 and 4. What about 3? No, 3 doesn't go into 8. What about 4? Yeah, 4 goes into 8. 2 times. 5? No. 6? That's an even number. No. 7 or 8. Okay, so 8 and 1. So these are our factors that go into 8. Next, let's list all the factors when multiplying 12. So how about 1? We know that 1 and 12, 2. Yeah, 2 times 6 is 12. 3. Yep, 3 times 4 equals 12. And we can, all right. So now let's look at our factors. Besides 1 and itself, what are the common factors that we see between 8 and 12? I'm going to use a different color here. Right, we see a 2. They both have a 2 in common. What about a 3? No, 8 doesn't have 3. What about 4? Yeah, we see 4 right here. 5? We know 6 is here. Is there a 6 over here? No, 6 doesn't go into 8. 7, 8. Okay, so now we know that 4 is the greatest common factor that goes into both 8 and 12. So which factors do we see in common between 8 and 12? We saw 2 and we saw 4. Between 2 and 4, which one is greater? Right, 4. So that's our answer. The greatest common factor of 8 and 12 equals 4. Let's move on to the second strategy. This is called the breakdown. Step 1 of the breakdown. Break down each number into its prime factors. Remember, prime factor is a whole number greater than 1 that cannot be made multiplied that cannot be made by multiplying other whole numbers besides 1 and itself. Step 2. Mark the common prime factors, including repeats. Step 3. Multiply the common prime factors. And that's it. There's only 3 easy steps. So let's get started. Example 1. What is the GCF of 40 and 50? Okay, so we have some room to work. Step 1. Break down each number into its prime factors. Okay, we know how to do this. So we have 40. What goes into 40? 2 and 20. Can we break down 20? Yes, we can. 5 times 4. Can we break down anything else? Yes, we can break down 4. So we have 2 times 2. Okay. Mark the common. So what do we mark the common prime factors? This is step 2, including repeats. So we have 1 2, 2 2, 3 2s, and a 5. Does 4 count? No, because we were able to break down 4. These are our prime factors right here. Okay, let's move on to 50. Can we break down 50? Yes, we can. We have 2 times 25. Can we break down that any more? Definitely. 5 times 5. All right, can we break down 5? No? Okay, then we're done. Let's circle our common prime factors. We have 2 5s and we have 1 2. Okay, now let's mark the common prime factors between each other. So we know, okay, so we see that there is 1 2. Okay, that's good. We have 1 2, one set of 2s. Is there a second set of 2s? No, there's not a second 2 in 50. Let's try 5s. Is there a common set of 5 in both of them? Here's a 5. Oh, here's a 5. All right. So we have another set of 5s. Do we have another set of 5s? We have here, but not over here on 40. So the only 2 common prime factors between 40 and 50 is 2 and 5. Step 3 says multiply these common prime factors. So 2 times 5 is 10. So now we know that the greatest common factor between 40 and 50 is 10. And that's our answer. Okay, guys, last example. What is the GCF of 15 and 62? We're going to do the same method that we did up here. So let's break it down. How do we break down 15 into what? Right, we can do 3 times 5. Anything else? Nope, we're done with that one. So we have 3 and 5 as prime factors. Remember, if you have trouble remembering what a prime factor is, you can either look in your notes or this video, or utilize the tools that you have. You can definitely type in Google prime factors, and it'll help you distinguish what are prime factors that you can use and observe. All right, let's break down 62. What goes into 62? We definitely know it's a 2 because it's an even number. So 62 divided by 2 equals, yes, 31. Can 31 be broken down? Does 2 go into it? No, it's an odd number, right? Because of this 1. What about 3? Well, I know 3 times 10 is 30. No, so that's not going to work. So I think we're done. Okay, let's mark the common prime factors that we see between 15 and 62. We have a 3 over here. Is there a 3 over here? No, this is 31. What about a 5? No. So what's happening here? There are no common prime factors between the two. So that tells us that the greatest common factor between 15 and 62 is 1. Because we know for sure that 1 goes into both 15 and 62. All right, everyone. That was your lesson on greatest common factors and how to find it. I hope you guys have a wonderful day.